Hello all, in this video I am going to solve question number 27A and B from CBSE class 10 standard math 2026 board paper. The question paper code is 30/1/3. The question 27A says, in the given figure, triangle ABC is a right triangle in which angle B is 90 degree, AB is 4 centimeter and BC is 3 centimeter. Find the radius of the circle inscribed in the triangle ABC. Let O be the center of this circle. Let's join C and O, A and O, B and O. Now we have divided this triangle ABC into three parts: AOC, AOB and BOC. Individually we can get the areas of these three triangles. When we do that, the radius of the circle becomes the height of each triangle. So then we get a connect to solve the radius of the circle. Area of triangle ABC is half times base into height, that is BC into AB, which is half of 3 into 4, which is 6 centimeter square. The sum of the area of the three triangles is also equal to 6 centimeter square. So area of triangle AOC plus area of triangle AOB plus area of triangle BOC is equal to area of full triangle ABC. For triangle AOC, OP is the height, and for triangle AOB, OQ is the height, and triangle BOC, OR is the height. OP, OQ, OR are all radius, so let us represent that with the letter R. To get the measurement of AC, AC is the hypotenuse of the triangle ABC, which is root of 3 square plus 4 square, which is root 9 plus 16, which is root 25. So AC is 5 centimeter. Area of triangle AOC is half times AC into OP plus area of triangle AOB is half times AB into the height is OQ plus area of triangle BOC is half times base BC into the height is OR, which is equal to 6 centimeter square. Half is common in all the terms. Within bracket we are left with 5 into OP is R plus AB is 4, OQ is R plus BC is 3 and OR is R, which is equal to 6. 5R, 4R, 3R. If we add all these three, we get 12R, which is equal to 12. So R is equal to 1 centimeter. The B part of the question says, in the given figure, if a circle touches the side QR of the triangle PQR at S and extended sides PQ and PR at M and N respectively, then prove that PM is equal to half of PQ plus QR plus PR. PQR is a triangle. Here is a circle. This circle touches this side QR at a point S. The side PQ is extended and PR is also extended. These extended sides touches the circle at M and N respectively. With these details, we have to prove this statement. Let's observe the diagram. P is a point external to this circle. PM and PN are the tangents from P to this circle. So PM is equal to PN. Q is also an external point to this circle. QS and QM are two tangents. So QM and QS are equal in measure. R is also an external point to this circle. RS and RN are two tangents to this circle. Therefore, RS and RN are equal in measure. Here, PM can be expressed as the sum of PQ and QM. PM is equal to PQ plus MQ, which is equal to PQ plus, in the place of MQ, we can write QS, since QM is equal to QS. Same way, Pn can be expressed as a sum of PR and Rn. Pn is equal to PR plus Rn, which is equal to PR plus Rn can be written as Rs, since Rs is equal to Rn. Let this be equation 1 and 2. Adding both the equations, on the left hand side we get Pm plus Pn is equal to pq plus qs plus pr plus rs. Pm plus, instead of Pn we can write Pm, which is equal to pq plus pr plus qs plus rs. 2 times Pm is equal to pq plus pr. Qs plus rs is nothing but this qr. So Pm is equal to half times pq plus qr plus pr. This is the statement that we have to prove. Hence, proved. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.